The object at the heart of the story is an extraordinary quasar which was first detected in 1998 during a radio survey. It appeared as an intensely bright, unresolved point of light, far too luminous to be a star. Early on, astronomers were not sure what they were seeing. The term quasi-stellar object or quasar emerged as scientists began to realize these mysterious points of light were unlike anything they had encountered before. Over time, the true nature of quasars came into focus. They are powered by supermassive black holes, millions or even billions of times the mass of our Sun, located at the centers of distant galaxies. These black holes are far from silent. They feed on surrounding gas and dust, forming a spinning accretion disk that radiates enormous amounts of energy. Some quasars also launch colossal jets of charged particles, searching across intergalactic space and reshaping their host galaxies. Quasars are among the brightest objects in the universe, often outshining the combined light of all the stars in their galaxy. They emit energy across the entire electromagnetic spectrum, from radio waves to X-rays. When their jets are pointed directly toward us, they appear as brilliant points of light, like cosmic lighthouses, making them easier to detect. This quasar has a brilliant accretion disk and is located in a giant elliptical galaxy. This black hole is extraordinary even among quasars. Located 12.5 billion light-years away, it allows us to look back to when the universe was just 1.5 billion years old. At the time of its discovery, it was the brightest known object in the universe. Surrounding it are immense clouds of hot dust and molecular gas, along with regions experiencing intense bursts of star formation. Studying quasars like this helps scientists unravel how early galaxies formed, how matter evolved, and how the universe built its first large structures. In the region surrounding this quasar's black hole, scientists have detected molecules never before observed at such extreme distances, including water vapor. Most of the gas around black holes is hydrogen, but under the right conditions, more complex molecules like water can form. Located 12.5 billion light-years away, it allows us to look back to when the universe was just 1.5 billion years old. At the time of its discovery, it was the brightest known object in the universe. Surrounding it are immense clouds of hot dust and molecular gas, along with regions experiencing intense bursts of star formation. Studying quasars like this helps scientists unravel how early galaxies formed, how matter evolved, and how the universe built its first large structures. In the region surrounding this quasar, scientists have detected molecules never before observed at such extreme distances, including water vapor. Most of the gas around black holes is hydrogen, but under the right conditions, more complex molecules like water can form. Around this quasar, astronomers found the largest known reservoir of water in the universe. This water exists not as liquid or ice, but as a vast, warm cloud of vapor around -53 Celsius, which is considered warm by cosmic standards. It is 5 times hotter and hundreds of times denser than the gas typically found in galaxies. The sheer amount of water is staggering. Its mass is equal to 25,000 suns and about 140 trillion times the water in all of Earth's oceans. Spread over hundreds of light years, the cloud is still incredibly diffuse, being 300 trillion times less dense than Earth's atmosphere. For comparison, the Milky Way contains roughly 4,000 times less water, and most of it is frozen as ice. In this quasar, however, the water mixes with other gases like carbon monoxide and molecular hydrogen. Detecting water so far away shows that the basic ingredients for life existed early in the universe's history. Water also helps cool and condense gas clouds, playing a key role in star formation. Discoveries like this provide crucial clues about the chemical evolution of galaxies. The detection of water around this black hole began in 2008 when Matt Bradford's team at NASA Jet Propulsion Laboratory used a Z-spec spectrometer at Culture's submillimeter observatory on Mauna Kea, Hawaii. Their observations were later refined with a combined array for research in millimeter wave astronomy in California. Another team led by Darius Liz's Caltech, using the Plateau de Bourg interferometer in the French Alps, confirmed the presence of water by identifying its spectral signatures. Bradford's team went further, identifying multiple spectral lines that revealed the enormous mass of water present. The water vapor around the quasar behaves like a natural low-frequency laser called a maser, with its beam aimed toward us. This natural maser forms when a dense cloud of identical molecules, like water, gets energized by an intense energy source. In this case, the quasar's powerful X-rays excite the water molecules. A small burst of light triggers the first molecules to release energy, which then stimulates others, creating a cascade of microwave radiation, all at the same frequency. As long as the black hole remains active, this cosmic maser continues to shine, powered by the black hole instead of batteries. Detecting this immense water reservoir required a perfect alignment of conditions: a bright, active quasar, a dense cloud of water vapor nearby, and its maser beam pointing in our direction. Thanks to this rare alignment, we have uncovered evidence of vast water reserves that existed when the universe was still in its infancy, just 1.5 billion years after the Big Bang. Thank you for watching Planet Spiral. Please like this video and subscribe to this channel, and I will see you in the next one.